All right, so what we are going to do next is we are going to take a break from Kodu and we are going to look at a mathematical concept called transformations and its application to game design. And specifically, we're going to look at the type of transformation called a translation and how we're going to use that very, very often in this class and how it applies to both Kodu and MonoGame. So, every time we have a moving object in game design, we have what's called a translation. And truly, anytime you're trying to move around a screen, you are applying some sort of translation to your objects that are in your game design picture. So, whether or not you realize it, we have a coordinate plane in the back of every game that we design. And essentially, just like in math, how coordinate plane tells you an XY location. So we'd have our coordinate plane, say we had the point, I don't know, say we had -1, 2. We'd go to x is -1, y is 2. That would be our location. So in game design, everything has a location using a coordinate plane. And then from there, we apply translations to essentially represent movement of those objects on a screen and to track where those objects were and where they currently are. All right, so as I said before, you want to think of how we keep track of objects in an XY plane. You'll notice here I have 5 different locations. And remember, this is just like math. You track your points using the coordinates. So A would be -6, 4. B would be 7, 6. E would be x is 5, y is 0. D would be 4, -7, and C would be -8, -2. So knowing how to track those locations and noticing that this will be a big part of what we're about to do in game design. So when you see a translation, it will commonly be written in this form right here. And what this is saying is whatever x is, you take x and add 4 to that x coordinate, and then you take y and subtract 5 from that coordinate. So, for example, if we look here at point A, we're going to add 4 in the x direction, which takes A to about -2, and then we're going to subtract 5, so 1, 2, 3, 4, 5. And if we double check, A is currently at the point -6, 4. If we add 4 to that x coordinate, okay, A prime is now going to be at -2. And if we subtract 5 from the 4, we're at -1. So we have A to represent where our point started. So we have A to represent where our point started. That was at -6, 4. And then where our point ended, we use that prime notation, so A prime, to represent where our point ended up, -2, -1. So what we can do here is we can do this with the rest of the points. I'm going to shrink that up a little bit. And we can do this with the rest of the points as well. So I'm just going to list, okay, B, C, D, and E. Point B is currently at 7, 6. Point C is currently at -8, -2. Point D is currently at, it looks like 4, -7. And point E is currently at 5, 0. So these are all going to be translated. So B prime, we need to add 4. That would be 11. Subtract 5. 1. C prime, we're going to add 4, so that's -4. Subtract 5, so -7. D prime, we're going to add 4, so I have 8. Subtract 7, -14. And E prime, we're going to add 4, which is 9. Subtract 5, which is -5. So we have those points of where they started, and then the prime notation tells where those points ended. And that notation will be very important as we move forward. That's how you will portray to me where the point started and where they ended after the translation. So the same thing applies when we're translating various points on a shape. And we're going to actually redraw the shape on the coordinate plane. So here it says we're going to subtract 3 in the x direction and add 2 in the y direction. So let's start here at point x. So point x is going to move backwards 3 in the x direction and then up 2 in the y direction. So that is the point x prime. And I'm going to mark, okay, x prime, the point where x prime is, it is now at -1, 2. That is where x prime moved to. And then let's do g in another color, so let's focus in on here. We're going to subtract 3 in the x direction and go up 2 in the y direction. So here I can see g prime. G prime is now at the point 1, 2. Then again, let's switch colors to do another point. Let's do in blue. We're going to focus in here on Q. So let's subtract 3. 1, 2, 3. Go up 2 in the y direction. So there's Q prime. And Q prime is at the point -1, 0. And then let's switch colors one last time. Focus in here on U. U, we're going to go back 3. 1, 2, 3. Up 2. So there is U prime. U prime is at the point 0 for x, -2 for y. And then if I take the time to actually connect these together, what I see is that entire shape has been translated going backwards 3 in the x direction and up 2 in the y direction. And notice that I'm using that prime notation to notate exactly how those points have been moved and where that shape was basically moved after the translation. All right, so we've talked a lot about how translations work in math and the math coordinate plane. And something to keep in mind when we start game design is that not all coordinate planes used in game design are set up like our math coordinate plane. And actually, a lot of them have a slightly different setup. So if you look here, this is how monogame will work once we get into monogame. And what you'll notice is 0, 0 is over here in the upper left-hand corner. It is not in the middle of the coordinate plane like it is in math. So a lot of times in programming, 0, 0 will be that upper left-hand corner. And then what will happen is x will increase as you go to the right, and y will increase as you go down, which generally is backwards outside of what you think. So this point right here, 1, 2, 3, 4, 5, this point here is 0 for x and a +5 for y. So it's a little bit backwards from what you expect, but it makes it a little bit easier. You know, 0, 0 is that upper left-hand corner, and then you're dealing with all positive integers as you move to different coordinate locations. So keeping that in mind as we start game design, this upper left-hand corner for 0, 0 is what you will see most commonly. So when you're trying to find a location for an image or something of that nature, keep in mind the locations on your coordinate plane are not identical to math. The translations apply in the same way, how you're moving x and y, and you use what you know about the coordinate plane, but this coordinate plane is a little different with 0, 0 in the upper left-hand corner. X will still increase as you go to the right, but y will now increase as you go down, which means that y decreases as you go up. So keep that in mind as we move forward. All right, so I want to practice writing some pseudocode on the screen using these concepts we just talked about. So we're going to write some pseudocode for Super Mario. It is going to cause Super Mario to move right, left, up, and down, and we're just going to write code in general. We don't know the exact syntax for the language we'll be using in this class, but we're just going to write in general so we kind of know, okay, we're brainstorming ideas of what we want to happen if those buttons are pressed. So if the right arrow is pressed, what do I want to happen? Well, if I think about the coordinate plane, if the right arrow is pressed, I want him moving to the right, which means that x would need to increase. So I would say, okay, x would need to add 1. And then from there, okay, if the left arrow is pressed, what do I want to happen? Well, I want x to subtract 1 so that he'll move to the left. And then from here, okay, I think if the up arrow is pressed, and this I have to think about a little bit more. Okay, if the up arrow is pressed, and I remember that this upper left-hand corner is 0, 0, when we're going down, y is actually increasing, and I want the opposite to happen. So I want to say, okay, if y is going up, well then y has to be decreasing, which means that y will equal itself and we'll be subtracting values to move up. And then the last thing we want to happen is if down arrow is pressed, y will then be adding 1 because we know that to go down, y is increasing on that coordinate plane that is commonly used in game design. So as we move forward, don't be afraid to brainstorm ideas. Okay, what would I do if I wanted to move in these different directions? So a couple of things you should constantly be thinking about are how we could extend this to move at different speeds, or what else we could do to mimic jumping and whatnot in game design. So a couple of things to think about. How could we make our character move faster? Well, realistically, we could just have him move at a faster speed. So maybe we're adding 5 each time. Maybe we are subtracting 5 each time, whatever it would be. That would make our character move faster because we would move more pixels every time the program itself ran. Then from here, how do we make our character move slower? Well, you could add something smaller, to do like x plus 0.5 or x minus 0.5, or you could do something like, okay, using the game counter to your advantage and saying, if the game loop has run five times, well, after the game loop has run 5 times, then you're going to do x equals x plus 1. So basically postponing and only adding 1 every time, every 5th time that code runs, or something of that nature. So you have to figure out how you want to track that. But there's a couple different options you have for if you want to make a character move slower. Then from here, how could we guarantee our character will fall back down to earth after he jumps? Well, this would take a little bit more planning, but you could say, okay, you know, if the up arrow is pressed, then maybe y equals y minus 15 to make him jump up. And then after that, if, maybe you'd say if my location is greater than, so say my location started at 50, if my location is greater than 50, then every time the code runs, it's going to add 1 each time to bring him back down to earth. So there's, again, a lot of different ways you can do this to mimic. He jumps up and then he slowly falls back down. So just being able to think outside the box of, I'm using translations, but how do I apply them a little bit further? All right, so now that we've kind of talked about translations in 2 dimensions, I do want to take it one step further and talk about translations in 3 dimensions. And if you think about it, I have this little image of this little guy in 3 dimensions, and in 3 dimensions, you need to account for a few other ways of moving. So yes, we move to the right, so I'm going to try and make it move to, okay, my pen. Make him move to the right, and make him move to the left. He can move up, he can move down, but then you also know, and this is a little bit harder to draw, he can go backwards and he can go forwards. So in 3 dimensions, we need to account for essentially, you see it, 1, 2, 3, 4, 5, 6 different dimensions, because we can move forward, backward, right, left, up, and down. So we need to account for this, and in order to do so, we need to have 3 axes on our coordinate plane so we can account for all 6 directions. And this is where those of you who have taken a little bit higher level math, the XYZ coordinate plane comes into play. So we will use X, Y, and Z, so we can have a positive and negative for each, in order to account for 6 different directions. Now, this is generally how I break it down. I say that X and Y is my forward and backwards. Y is my left and my right, and Z is my up and my down. So I can track all 6 directions. So obviously a positive X, negative X, positive Y, negative Y, positive Z, and negative Z. So I want you to take a little time and imagine where these points in 3 dimensions would end up. So here, if we're going to go to the point 4, 2, 5, go to 4 on 1, 2, 3, 4 on the x-axis. Then we're going to move out 2 on the y-axis. And then we're going to move up to 5 on the z-axis. 1, 2, 3, 4, 5. And now this is a little hard to do on a 2-dimensional piece of paper, but that's kind of the process we go through. And then we go to x, okay, negative 3, 2, and then up 1, 2, 3, 4, 5, 6. And imagine that that's actually in the middle of the air, not drawn on a piece of paper. And the last point, negative 4, negative 1, negative 5, would probably end up somewhere around here. Again, extended in the middle of the air, just like 3 dimensions would be. Now, you can see that these are actually really hard to draw on a sheet of paper accurately. They're really easy if you have a 3-dimensional plane that's 3Ds right in front of you where you can trace the points and hold it up in midair. However, they're hard to draw, and as a result, I'm not, and I repeat, I am not going to require you to draw these translations and these coordinates on an assessment. Instead, I'm going to ask you to trace these points and tell me the location of these points. So you do have to understand how the 3-dimensional plane works, and if you want to cut out a 3-dimensional plane, please let me know. I can get that for you, and we can visualize how these 3 dimensions work. However, if I'm actually asking you where your points have ended up after your translation, I'm going to ask you for the coordinate points. I'm not going to ask you to draw your own 3-dimensional plane, because as you can see just from the drawing that we did here together, that this can be a little bit challenging to do. So I want to give you an example of a 3-dimensional translation that I will have you do. So our first transformation you can see is going to be a translation where the x-coordinate subtracts 2, the y-coordinate stays the same, and the z-coordinate adds 5. So I'm going to write down my A point here, A, 5, 3, negative 8. And I'm going to say, okay, A prime. This point is getting this translation here. So I can see the x is subtracting 2, 5 minus 2 is 3. The y value has no change, so it stays 3, and the z value adds 5, so at negative 8 plus 5 is negative 3. Then from here, b, okay, this translation is the exact same translation, so I have negative 4, 1, 0. B prime, I subtract 2 from negative 4, which is negative 6. Y stays the same, and z is 0 and adds 5, so it becomes 5. And then c, we have negative 5, 0, negative 3. And then c prime, the point I'm translating to, I'm subtracting 2, so negative 7. 0, the y stays the same. And I add 5 to negative 3, which is 2. So I'm not asking you to draw these out. When I ask you to do the translations in 3 dimensions, I am asking you to list the points that they would be translated to. So show me A prime, B prime, and C prime. All right, so the last thing that I want to talk about is I want to talk about what if I'm asking you to do 2 translations in a row. So I'm asking you to translate A, B, and C to one point, and then later on it gets translated to another point. And how would we track that, and what would you do if I asked you to do 2 in a row? And it's not that much different than what we were doing before. So let's take A, which is at the point 5, 3, negative 8. And let's do this first translation here. So I'm taking the x value and I'm adding 4. So I should have good notation here, first of all. Let's make sure I'm labeling my points accordingly. So I have A prime, that's what I'm translating to. I add 4, so this becomes 9. subtract 3, so it becomes 0, and add 2, so that's negative 6. Then let's do the same thing with B. So B is currently at negative 4, 1, 0. The first translation is applied, so I add 4. So the x-coordinate of B prime is at 0. Subtract 3, so I'm at negative 2. And add 2, so I am at 2. And then here, okay, C is currently at negative 5, 0, negative 3. And then I'm going to add 4. So the x-coordinate of C prime is negative 1. Subtract 3, that is negative 3. And add 2, that is negative 1. So I've applied that first transformation of a translation that has taken me to my prime points. Now from here, I need to apply the second one. And the second one I apply to my prime points because after the first translation has occurred, that's where my object is. And that prime, those prime points, are what are then being translated to the next set of points. So here I'm going to apply my second transformation. So here I'm going to go to A and I have to label this double prime because this is the second time I am moving. And I'm taking 9 plus 2, which is 11, 0 plus 5, which is 5, and negative 6 minus 3, which is negative 9. And then from here, okay, B double prime, at 0 plus 2 is 2, negative 2 plus 5 is 3, 2 minus 3 is negative 1. And then C double prime, we have negative 1 plus 2, which is 1, negative 3 plus 5, which is 2, and negative 1 minus 3 more, which is negative 4. So at the end of all of these translations, my image will be here at the double prime point. So both translations have occurred, and as a result, I am located at those points labeled A prime, B prime, and C prime. So now you are done with this video, and if you are ready to go, you can come see me and I can give you the assignment for this lesson.